Right, hello. Welcome to this review of acyl chlorides, and what we'll be looking at is what they are. We're going to be talking about how to name them and also discussing some of their reactions. So let's get cracking. So acyl chlorides, they kind of often get renamed as acid chlorides, so I'll probably use the names independently or interchangeably throughout this, because I can never choose which one to use myself. So start off by saying what they are. So they are a carbonyl compound. So they're going to have a carbonyl C double bond O. And I'm going to just draw a simple one out here. And what we find with these ones is a bit like a carboxylic acid. They've got a different group attached to the carbonyl carbon, but this time it is a chlorine that's joined onto there. So a carbonyl, and it's got a chlorine attached. Now these are made from carboxylic acids in a reaction with phenyl chloride. For AQA you don't need to know that, but some other exam boards you do, so just be aware of that if you see it around. So how do we name these? Well, they're very similar to carboxylic acids. So if I draw a carboxylic acid here, so I would name this one, I've got 2 carbons in there, so this would be ethan, and because it's a carboxylic acid, I'm going to add oic acid at the end. For our acid chloride, acyl chloride, again it's got 2 carbons in it, so it's the same stem as the carboxylic acid, but this time we're going to finish it off with oil chloride. So ethanoyl chloride. So it's relatively straightforward. You just got to recognize the acid that it's derived from and swap out the oic acid for oil chloride. And as if by magic, 3 molecules have just appeared. So let's go and have a little practice at naming these. So here I've got 1, 2, 3 carbons in a row. Then I've got my carbonyl. So this would be propan oil chloride. Okay, so from propanoic acid we made propanyl chloride. This time I've got a methyl group on this second carbon, and we've got 1, 2, 3 carbons in the chain. So this time it's going to be a propanoyl chloride again, because it's 3 carbons, propanoyl chloride. But I've got this methyl group on there, which I'm going to have to put at the front here, so it's 2 methyl propanoyl chloride. Now, last one here, because everybody loves skeletal formula. I've made the last one a little bit long, I've not got a lot of room here. Done this out, so let's have a look at what we've got here. So we've got 1, 2, 3, 4 carbons in a row. So our longest chain is 4 carbons. So I'll write it a little bit higher, this one. So it'll be butanoyl chloride. And now we've got to think about where the methyl group that I've got up here is. So a bit like other molecules where we've got only our functional group has got to live on the end, this becomes the number 1 carbon. So this time this is 1, 2, 3, so it would be 3 methyl butanoyl chloride. I missed an E off the end there. There we go. So yeah, there we go, naming them. So oil chlorides. So key points here: take the acid name, knock the oic acid off, replace it with oil chloride. Name the longest carbon chain in there, that becomes your main part of the name, and then just look what else you've got dangling off there. And remember that the ethanoyl chloride, or the oil chloride bit, the functional group, will take the number 1 carbon. Right, so let's move on to reactions of the acyl chlorides, and there are 4 that we're going to look at. So we're going to look at the reaction with water, the reaction with alcohols, with ammonia, and finally with amines. So water, alcohols, ammonia, and amines. So we're going to start off by looking at water. Now, the one thing to remember for all these is they react vigorously. Oops, my spelling's bad today. Vigorous reactions. I will try and mention it as we go along and remind you, but do remember that these are all quite aggressive kind of reactions. So let's look at the reaction with water. So I'm going to start with, let's say, ethanol chloride. So I'm going to draw out my molecule here. I'll put my chlorine in. I feel like I'm going to use green for chlorine because that's the standard colour for chlorides. Cl, there we go. I'm going to react this with some water. What we're going to make from this is we're going to form our carboxylic acid. And we will release a small molecule, HCl. Now, one thing to kind of remember about these is they like to ask you questions about what you're going to observe. So because we're producing HCl, HCl would be a gas in this case, and we would see this coming off. So we'd see steamy fumes. So the gas is released. It reacts with water quite quickly, any water in the atmosphere. If you take a lungful of this, it'll dissolve and then turn into hydrochloric acid and do some damage to your tissue in your lungs. So it is a little bit of a nasty reaction to do in the lab. You've got to be careful, make sure you're in a fume cupboard, because you are producing this corrosive gas. Now, the point of this reaction is not very much, so why would we want to be making this carboxylic acid when we took this carboxylic acid to make our acid chloride in the first place? I guess one of the things that you could look at is it could be a test for a acid chloride, so these mythical situations where all the labels are falling off all the bottles in your lab, you'd put a drop of water in or you'd test it with a little bit of water, you might see these steamy fumes given off. Another possible use of this is if you've done a reaction and you might have a little bit of leftover acid chloride, you don't know, and you want to just neutralize it, get rid of it somehow. You could add some water to it maybe, I don't know. Not a lot of point in the reaction, but just be aware of it, and remember it is a vigorous reaction. It's quite exothermic, happens quite quickly, so yeah, so think about those when we discuss them. So that's with water. Now we're going to look at, with alcohol. So I'm going to take my acid chloride again, my ethanol chloride, and I'll put my chlorine on, and this time I'm going to react it with let's say methanol. So I've got CH3OH there. This is going to react. Going to keep my original bits here. This is where I always mess up with my colours. So now OCH3 is replaced there, and we're going to make another small molecule of HCl. So here I've made my HCl again, so I would expect to see these steamy fumes given off, and sorry, my pen is encroaching on the screen, and we've made this molecule here. So what have we made? Well, we've got a carbonyl, an oxygen, and then an alkyl group. So we've made an ester. So this would be methyl 1,2 ethanoate. So methyl ethanoate. This is actually quite a convenient way of making esters. It's a lot quicker than doing it by the reaction of an acid and alcohol. It happens fast, and it's a vigorous reaction. It's going to give off some heat. So yeah, it's a good reaction, this one, and you may very well do examples of these, and you will see these in parts of your exam. Right, cracking straight on. I'm conscious we're approaching 10 minutes, which is a long time for one of these videos. Let's look at ammonias. So ammonia. So we'll start with our ethanol chloride again. This time I'm going to react it with ammonia. So ammonia, NH3. So what do we think we're going to put on here? Well, it doesn't take a genius to work out we're going to attach our nitrogen. So our nitrogen is going to keep 2 of its hydrogens there, and our molecule that we're going to produce at the other end as well, our byproduct if you like, will be HCl. So this kind of compound, you may or may not have met these before. When we have a nitrogen joined onto a carbonyl carbon, a C double bond O, we make an amide. So this one has got 2 carbons in, so it's F an amide or ethanamide. Okay, so you might have encountered these in polyamide type things or proteins, those kind of things, these kind of joins together. But yeah, we're producing HCl, some steamy fumes probably is being seen. Then again, you've started with ammonia, which is also a gas anyway. So yeah, there we go. So last one, we're going to look at an amine. And my green chlorine. And I've now run out of colours, so let's have a couple of these here. We shall have CH3 NH2. Okay, so this molecule here is methylamine, sometimes pronounced methylamine, and if you're American it'd be methylamine, for all those people who enjoyed watching Breaking Bad. Right, what are we going to make with this one? Well, it's similar to the reaction above with ammonia, but we've got another alkyl group to worry about. So that's my chunk from my acid chloride. What's going to join on? Do we think it's going to be the methyl end or the ammonia end or the amine end? Well, it's the nitrogen that joins on, and when we look at the mechanism we'll see that a bit more clearly. So here I've got NH, and then the methyl group is going to still be attached to this bit here, CH3, and I've made my HCl over here. And I've just daubed my Sharpie all over the wall. I'm going to be in trouble. Okay, so the last thing to do on this one is, what can we name this thing? Well, it's 1, 2, so it's going to have some F's in it, isn't it? And what we've made is an N-substituted amide. So it's ethanamide, like above, but we need to sort of describe what this group here is and where it is. And because it is attached to the nitrogen, we would say it would be N-methyl. So the N in our name is telling us it's attached to the nitrogen. In this case, you probably wouldn't need an N in it, but because we call them N substituted, we are going to have it in there. If this carbon chain here becomes longer, and there'd be the potential of having a group on it, so for example, I've not got a lot of room here, I'll move over to this bit. Say I've got 1, 2, 3, 4, so say my methyl group is there. I could have a methyl group attached to, say, this carbon there, and this would be a primary amide. So it is important to get that N in the name. Hopefully that makes sense. So this one up here, so I'll now name it while I'm here. So this one will be N-methyl 1, 2, 3, 4, 5. So pentanamide. So the top one N-methyl pentanamide. And the bottom one here would be 1, 2, 3, 4, 5. It's pentanamide again. But this time I'm going to number my carbons from here 1, 2, 3, 4, 5. So on the number 3 carbon here, I've got a methyl group. So this one would be 3-methyl pentanamide. So 2 isomers there. Very, very similar. The only difference is one, the methyl group is attached to the nitrogen, and the other one is attached to the carbon chain. So I mentioned before about what happens with ethanol chloride reacting with ammonia to make this ethanamide and HCl. Now, I want to think about an alternative situation of this. So if I don't have an exact stoichiometric amount of this stuff, we don't make this HCl. Now, I want to talk about this now because we'll mention it in the next video when we look at the mechanisms. Generally speaking, we're going to have more of this hanging around, and this stuff is going to react with the hydrochloric acid. So if you're asked to write an equation for this, what we can say we have or have got, so instead of 1 ammonia, what we're going to do to form our product over here is we're going to have multiple ones of these. Okay, so what happens is one of the ammonias reacts to form, apologies there, that should go to 2, to form our amide, and the other one has a sort of a side reaction almost, reacts to form an H4Cl, so ammonium chloride. So what we would have is, so where this ammonium chloride might come from, like a neutralization reaction between NH3 and HCl. It forms the ionic compound ammonium chloride. Okay, so just watch out for these and look at what we're going to be making. Like I say, it becomes important when we look at the mechanisms, and I discuss that in the next video. So certainly if it ever mentions excess of ammonia and I want you to write an equation, you need to make sure that you're doing it this way. So very quickly in summary, we've looked at how we name them and how we take the acid name, knock off the oic acid and end in oil chloride. We've looked at the structure of them and how we have a carbonyl group, with a chlorine attached to it. So made from carboxylic acid, so it's derived from them, which is where we get the name acid chlorides from. And we've looked at some reactions. So we've looked at the reaction with water, which looked pretty pointless, but we saw the steamy fumes of HCl being released. We've looked at the reaction with alcohols and how we use that to make an ester. That made a carboxylic acid, didn't it? I should have written that down. Carboxylic acid. And we looked at the reaction with ammonia and how this made an amide. And say that was a primary amide. And we also looked at the reaction with amines, and these made N-substituted amides. And some of these type of reactions you might encounter when we make aspirin, which is a common one and a required practical on AQA. So I'm going to leave that there. Hopefully it was some help. If you want any additional things or if you've got any questions, let me know, and I will do a video on nucleophilic addition elimination reactions, so the mechanisms of these reactions soon.